Hi guys. Today we're going to take a look at question 5 from paper 1 in the 2015 exam. Alright, so we have an equation x equals the square root of x plus 6. Okay, so not a whole lot of information to go on, so let's just write down the information we have. So our equation is x equals the square root of x plus 6. Alright, so whenever you have a square root expression, it always helps to try and get rid of it. Alright, so let's square both sides. X squared equals square root of x plus 6 squared is just x plus 6. Okay, so, and now if we move everything to one side, x squared minus x minus 6 equals 0. Well, now we have something that we know we can solve, because this is just a quadratic equation. So we write down our quadratic formula. X equals minus b plus minus the square root of b squared minus 4ac all over 2a. Okay, so our a in this case, a equals 1, b is minus 1, and c is minus 6. Okay, so if we just plug these into our formula, we get two solutions. X plus equals minus 1 plus the square root of minus 1 squared minus 4, 1 minus 6 all over 2 by 1. Okay. And our second solution is, again, minus 1, this time minus the square root of minus 1 squared minus 4 by 1 by minus 6. All over 2. 2 by 1. Alright, so what do these equal? Well, this we get 1 plus the square root of 1 plus 24. So square root of 25. The square root of 25 is just 5. So we get 1 plus 5 over 2 is 3. And this we get 1 minus 5 over 2 is minus 2. Alright, so let's try these in. Let's try these into our equation. Does 3 equal the square root of 3 plus 6? Let's just to confirm, does 3 equal the square root of 3 plus 6? Yes, it does. Alright, so that makes sense. Just because we don't want to end up with a minus inside the square root. And does minus 2 equal the square root of minus 2 plus 6? But this does not work, since the square root of a positive number is positive. So our answer is x equals 3. So now let's look at part B. Differentiate x minus the square root of x plus 6 with respect to x. Okay, so we're going to differentiate x minus root x plus 6. Okay, so our expression this time is x minus root x plus 6. Okay, and we've got to differentiate. Well, let's differentiate one thing at a time. Well, let's differentiate x, and that's just 1. So we get 1 minus. Now, this is the tricky part, differentiating the square root of x plus 6. Okay, well, what do we know? Well, we know that the square root of x plus 6 is the same thing as saying, so x plus 6 is the same as x plus 6 to the power of a half. If you know your rules of indices. So, and this makes it easier because we know how to deal with a function of the form x to the, let's say, a. It would just be, if we differentiate this, we would just get ax a minus 1. So now we can just do the same thing. So the derivative of x plus 6 to the half is a half x plus 6 to a half minus 1, which is just minus a half. And, well, what's x plus 6 to minus a half? What would that look like? Well, we know that if we do it to the minus, it's the same as 1 over the thing, and then a half is just a square root. So this we could just write as 1 minus 1 over 2 square root x plus 6. So that's just it. So the derivative is 1 minus 1 over 2 root x plus 6. Although, to be honest, if you write it in this form, you're going to get full marks, I would imagine. It's just, it looks a little bit nicer like this. Okay, so on to the third part of the question. Find the coordinates of the turning point of the function. Y equals x minus square root of x plus 6 when x is greater than minus 6. Well, x is greater than minus 6, that's just so that we don't have any negative values in the square root. So here's our function, and so we're looking for the turning point. Okay, so our function is what we've been working with. Y equals x minus square root of x plus 6. Okay, so when you hear turning point, immediately you should be thinking derivative equals 0. Turning point, dy dx equals 0. Let's just call that the derivative. So this is the point at which the function does something like, let's see. Does something like, let's say, this. So the turning point would be right around here. And if you notice, at that turning point, that derivative is right around 0 at that turning point. Okay, so how are we going to find when the derivative equals 0? Well, luckily enough, the previous question was finding the derivative. So we know that the derivative of this function, because we're looking at the derivative of x minus the square root of x plus 6, which is what this function is, we know that the derivative is 1 minus 1 over 2 root x plus 6. Dang it. So we need to let this equal 0 and solve for x. We want to find the x coordinate at which this happens. So if we multiply, if we bring the this over, we get 1 equals 1 over 2 root x plus 6. And then we multiply both sides by 2 root x plus 6. Or we could just multiply by root x plus 6. So 2 root x plus 6 equals 1. And now remember, whenever we have a square root, we always try and get rid of it. So we square both sides. And 4 by x plus 6 is equal to 1. So x plus 6 equals 1/4. And so x equals 1/4 minus 6. And this is minus 23 over 4. Okay. So when the function turns, x is minus 23 over 4. So if x is minus 23 over 4, what is y? Well, we can just plug minus 23 over 4 into our function to find y. So we have y is equal to minus 23 over 4 minus 23 over 4 plus 6. And so we get minus 23 over 4 minus the square root, and 6 minus 23 over 4 is just 1/4. And the square root of 1/4 is simply 1/2. So we get minus 23 over 4 minus 1/2. And this will give us minus 25 over 4. So our x coordinate is minus 23 over 4, and our y coordinate is minus 25 over 4. And so these are the coordinates of the turning point. So the trick here is to know that the turning point occurs when the derivative is 0, and using our prior knowledge on that derivative to solve for x and then plug that x into the function.